Yes, Shahid, am I audible to you?
Yes, ma'am.
All right. So in the last class, we had started with electric potential. So basics of it we had discussed, which I just wanted to brief you from class 11th, like work done's formula F dot S and work energy theorem, work potential energy theorem, and conservative forces. The formula that we have to use here and which we have already discussed is the formula of work done, which is Q integral of E dot dr. This is also used from point A to point B. One more formula you have. This is the same formula. See, this is potential. Remember, work done was charge into potential. So this is charge into potential. And what is the formula of potential? E dot dr. Depending upon that, we have a question here. Do one thing. Note down this formula and this question first. Then I'll discuss the solution with you. Here is a triangle given, right angle triangle from A point to B point and from B point to C point in the second part. All you have to use is this formula. Note it down, then we'll discuss this.
Ma'am.
Written?
Yes, ma'am.
Fine. See, electric field is given to you y I cap plus x j cap. So you have electric field's value and the charge that we are carrying is electron. Now, these types of questions we have not discussed in the class, so pay attention over here. Formula we already know for the first part and second part. Work done from A to B, this will be charge integral of E dot dr only from A point to B point now. Now, what is the charge that is being contained? That is electron, so we will write it as minus E. Charge is minus E. Integration, electric field. What is electric field given? Y I cap. This is y I cap plus x j cap. This is the formula. And dr, what will dr we'll choose? See, this is on x-axis, right? So we have to take x-axis and that is the unit vector which we put is I cap. See here, y I cap plus xj cap multiplied to dx I cap. So j cap has no component. J cap has no component. What are we left with? Look here, minus E y I cap integrating. What are the values given? From 0, we are integrating it to A point is 0, 0 and this B point is 2, 0. Right, so we are integrating this from 0 to 0 because this is x-axis. So this becomes integrating it from 0 or 0 to 2 even if you choose, but actually it is x equal to 0 to x equal to 2. And what are we left with is y dx. What is integral of y dx? Have you studied in maths?
Y square by.
No. Will we be able to do y square here? Y dy gives you y square by 2. Y dx also gives you y square by 2.
No.
No, it means y is 0 in this case. When you have no y dx, x, dy, such types of variables left, it means y is 0. And if y is 0 means the entire term becomes 0. So work done in the first part is actually 0. So in your options, you will be having the values when you will solve y as y square by 2. Whatever value you will obtain, that will also be present in the option. This is how we solve the first part. Coming to the second part, from 0 to 2, B to C. Again, the same thing we will do. See here. Second part is from B to C. So work done by the external force. This will again be minus Q, or we can write it as minus E as well. Minus E, the electronic charge, integrating. Now, this is y I cap plus x j cap. Now the variable, this is from 0 to 2 again. Instead of dx I cap, now we have dy j cap, because this is y variable, right? So it was from 0 to 2. Now it is from 0 to 2 again here also. So we are left with dy I cap. Again, I cap, j cap has no component. So when you will differentiate it, you'll multiply it. J cap is left with no component. So what are we ultimately left with? Minus E, integration from 0 to 2, y dy. We are left with y dy, right? This is y dy. And this becomes 0. Now can you solve y dy?
Yes, ma'am.
Now you can tell the answer, no, which you were mentioning for the above part. That is, this becomes y square by 2, limits from 0 to 2. Now this is valid because this is y dy. If you have y dx, then that is not applicable. So this minus E, you put the upper limit first. Now as you go by the integration, normal integration, the answer will be same, by 2. So that becomes minus 4E by 2, right? Minus 4E by 2, no? So this becomes minus 2E. This is the work done. If you want, you can put in the value of electronic charge. So answer will be minus 3.2 into 10 to the power minus 19 joules. That will be your complete answer. This I have left the value of electronic charge. All right, note down the solution. Done, Shahid, till here?
Yes, ma'am.
Fine. Now see, all the rest of the topics which come in between, we have already discussed in the class. So nothing different comes there from in your JEE, different from your CBSE. So everything remains same, but just quickly we'll discuss the formula at least. So you remember the formula or not? What is the relationship between electric field and potential, Shahid? What one formula?
E is equal to minus dV by dr.
Very good. E is equal to minus dV by dr. This is the scalar potential, and this is entire is the potential gradient. Good. This is the formula that we use. Apart from it, you know the formula of work done, that is charge into potential. So that is used. And sometimes potential and potential differences are made. So that means final minus initial. Yes, what is the electric potential due to a point charge?
KQ by R.
KQ by
R.
KQ by R. Very good. This is KQ by R. So all the questions also on KQ by R are same. So whenever you are revising, do go through the class notes as well, because some questions there also we have done. These are extra questions which you are only doing for your JEE. All right, now coming to superposition principle. See what type of superposition principle will be applied over here. What will be the superposition principle here? If I want to find out the net potential due to individual potential. Let's say there are V1, V2, V3, V4, nth number of potentials. How will I find the net potential at a point?
Add all of
Add all of them directly, algebraically, like V1 plus V2 plus V3 up till Vn. I don't need to take their vector sums. Vector sum is not required over here, right? And one more thing which we have studied, that is work done by the electric field. This is negative of the work done by the external force. This also a question also you have done this already. Now coming to potential due to dipole. So if for a
what
generalized
is E work done? EF.
EF is electric field. Work done due to
Oh.
electric field is equal to the work done by the external force. One more thing, Shahid. What is the formula for dipole potential due to dipole generalized case?
KP cos theta by R square minus R square.
R square minus
X square.
A square. This
No, only R square.
only R square. I have not asked you to approximate it. R square minus A square cos theta. All right. R square minus A square cos theta. Now, when you consider this dipole approximation, then it becomes no Kp cos theta divided by R square. But if you're not talking about ideal dipole approximation, if you do not know whether your A is very less than R, then only you are able to apply this, right? So these conditions you have to already see. So if we talk about axial line and equatorial line, then Shahid, what will be the formula for the dipole moment, the potential due to dipole, axial line and equatorial line?
It will be 0.
For equatorial, it is 0, right? Equatorial, it is 0. And for axial?
Minus KP.
Minus Kp. Why minus?
Cos 180.
Why would you take cos 180? This is your point. This is just 0 degree. This is exactly on the line. See, when we were doing magnetics, were you there in the magnetics class? First class which we had.
Oh, yes, ma'am.
Huh. So remember there one question we had seen: A point, B point, C point, finite, semi-infinite, and B point was on the axis. So when something was there on the axis, which angle did we consider? We took no sine 0 degree. That's why entire magnetic field came out to be 0. Same thing is applied over here. Because you are taking the point exactly on the axis. Why anti-parallel? You are considering it parallel. Theta will be 0. Always remember, axial line means only that theta is 0. Fine. So this becomes Kp divided by r square because this term finishes off. So remember, for a point charge, this conclusion remember for your statement-based questions, because this has been asked once and that too recently. Just this difference, that potential for a point charge, this is inversely proportional to the distance. But when we talk about potential due to a dipole, that becomes inversely proportional to r square. Fine. And when we talk about electric field due to point charge, it is inversely proportional to r square. And when we talk about electric field due to dipole, it is still inversely proportional to r square. So statement-based questions are asked upon this. Let's practice a question from here. But before that, before we go on to the question, from here, just quickly write down all the points so that it gives you a revision also and you have them written together. Then we'll practice questions. In this lesson won't take time. By next week, we'll be on current electricity only. This is a short lesson in comparison to your first one, but certain important questions are there, which I want you to write it and try. See, Shahid, you can write this question later. All together with the solution you can write. I want you to just participate right now. See, it says that two electric dipoles A and B with dipole moments dA and dB as given separately on the x-axis with R separation. This is the separation. Figure is already given to you. This says that distance from A at which both produce same potential. Distance from A at which both produce same potential. A point I'll discuss, then the same question I will give you with B point, so that you will tell me by yourself. It's not a very difficult question, but since it has come in your exam twice, we will discuss it once. An easy question, you will be able to even solve this. A point is there, B point is there. Let's take a point, P point. Total separation is R. So this part will become R. Let's say this part, let's take it as X. Let's take this part as X because we have to find it from A point. So this becomes R minus X. Now, if it says they produce the same potential, what is the potential when dipole moment is given? What is their potential when dipole moment is given? So see, the formula we have seen, it means potential at A is equal to potential at B. So Kp by R square we write. So this time this becomes Kpa by Ra square is equal to Kpb by Rb square. Question is not tricky. It's just that you have to solve this question very fast. I'll give you a very small amount of time in which you have to solve, but you will be able to do. Let us just see, because this is not a tough question. This is just how your speed improves. Minus 4qa I cap is the form for potential given. 4qa, that means charge into separation by Ra square. What is the separation from A? X square. B is given as 2qa divided by, what will be the separation of B point from that? R minus X whole square. So AQ gets cancelled. This 2, this becomes 2. Let's take root on all the sides. So this becomes root 2 by x equals to 1 by r minus x. So what is the value of x we are getting from here? Or let's cross multiply first, because x is there here also, no, the denominator. So we won't get our answer in one line. 1 by r minus x. So this becomes 2 root r minus root 2x equals to x. So 2 root 2r is equal to x plus root 2x. Now we can take 2 root r is equal to x, 1 plus root 2. Finally, your answer x is 2 root r divided by 1 plus root 2. Now I will show you how the options are actually made in your exams. This is the answer. This is clear first, tell me, Shahid.
Yes, ma'am.
Okay. So see, write down the question, write it till here. I'll give you a proper timer so that your speed improves day by day. And you will notice by yourself how the formula, how the options are given in the questions. Note it down first. Let me know when you are done. All right, unmute yourself and tell me that you have completed. Then we'll discuss something else from this question only.
Done, ma'am.
Okay, now see, Shahid, same question with just instead of A point, B point. And see, I'll start the timer in 30 seconds. You should be able to complete this. All right, start.
Yes, ma'am.
Okay, in 30 seconds, you should tell me the answer for B part. Yes, Shahid, done.
Yes, ma'am.
What is your answer coming?
R by root 2 plus 1.
R by root 2 plus 1.
Yes.
R by root 2 plus 1 wasn't this answer from A point.
For B point.
Okay, you are just getting R by
Root 2 plus 1.
R by root 2 plus 1. Let me discuss one. See, I think the answer is wrong, but I do not remember it exactly. Let me solve it with you again. If it is for B point, then this is K 4QA divided by, see, if we have taken, simply we have to subtract R minus this whole term. But instead of doing that, let's take X from here. Or even let's do one thing. Let's take A as R plus X simply. This take it as R plus X whole square for a region that you're taking. Right. Or one thing you can do, you can, when you have to, you know the value of X, so you can subtract R from that value also. R minus, what did we get? Root 2. What was the answer?
I took P to B as X and A to B as R minus X.
You have shifted these two. All right. So X way, yes, in X way you should get.
Yes,
You're
ma'am.
getting root R by root 2 plus 1. No. Or R by root 2
No, ma'am.
plus 1. R
R
by
by root 2.
plus 1. R by root 2 plus 1 should be the answer. Let me check. See, K4QA. This you have taken it as R minus X whole square. No. And this becomes K2QA by X square. This gets cancelled. This becomes 2. Right. So this becomes root 2 by R minus X is equal to 1 by X square. Till here you have done this?
1 by X.
Oh, 1 by X. Yes. 1 by X. So this becomes root 2x is equal to R minus X. So root 2x plus X will be R X root 2 plus 1. Yes, right answer. X will be R by root 2 plus 1. Good. So you were able to solve it in exactly 30 seconds. Very good. This is the speed in such types of questions, because this is not a difficult question. It just looks lengthy because of these values, I cap and 4 minus 4K. Usually the dipole values are not given like this. So this looks at one glance, if you see, but you can see it's a very, very easy question. You just have to equate it. It's just the equilibrium of two things as if you have taken. Right. Fine. Now see, coming to electric potential due to hollow conducting, non-conducting, and solid conducting sphere. This because we haven't discussed. This is also important for you. Dipole. So from dipole moment, only these types of questions are asked. Dipole moment in your class notes also we have done good questions. And one more thing, Shahid, from your superposition principle, remember some questions we have done where a square is given at this particular point. Due to all of these, you have to find out the potential. This becomes root A by root 2. Remember?
I joined the class late. Just wasn't there in the beginning of the chapter.
You have not attempted this. When did you join?
During this one, E minus E is equal to minus dv by dr from that.
Okay, so entire first lesson was also missed by you.
Yeah.
All right, all right. Then it's good that we have discussed the first lesson into detail. Fine, Shahid, fine. One question which I was referring to. Okay, I'll show you in the class. I'll show you if you've joined from minus dv over dr. I'll show you that question because those types of questions come in your exam, and that's an easy question that come in your both exams. So electric potential due to hollow. C, conducting. Conducting means it is able to accumulate charge on its surface. Hollow, it is empty from inside. Non-conducting means charges are going within the sphere. This is what is meant when we say non-conducting. Or solid conducting means it is not empty from inside as well as it is not allowing the charge to be present inside. Do you know the differences between these three or should I let you know?
I don't.
You know it?
No, ma'am.
See, I'll draw the figure then. By the figure, no, you'll be able to remember it better. When I say hollow conducting means nothing is present inside. Hollow, you already know. Conducting means when the charges are just present on the surface. You are not allowing this particular sphere is not allowing the charges to move within the sphere. So usually whenever you have no conducting sphere, only the term conducting area is mentioned. Keep in mind you have to include the charges which are residing above. It means you have to include the surface charge density because many questions relate to you with surface charge density. When we come to the fact non-conducting means charges are present within also. Usually dV, delta V, that is rho is used. dV over dA, volume per unit area. Volume is usually made in reference with superficial charge density we use here, but we come to volumic charge density. And solid conducting means the sphere is filled. This is not empty. This is not hollow, but the charges are present outside. This is actually the difference. Just try to identify them. Remember their formulas. You have to remember. Three things we will consider for all of these. For all of these, we just have one same formula. So if any of these you see in the exam, apply the same formula. But it's just that you have three regions. One is outside. Suppose the radius of the sphere is r and the separation from the center to the point of calculation, this is small r. So this is one region outside. Second region means on the surface and third region means inside. So when I say first region, that is outside. So formula will be kq by small r. Consider this. It becomes confusing when you are solving whether it's capital R or small r. So it's small r. Potential will be P outside. Second is not inside. Second is on the surface. Second is on the surface. So when we are talking about the surface, kq by capital R, this R. And coming to inside. See, inside and surface are same here. Inside and surface are same in case of potential. This is the only quantity when inside and surface become same. And one more thing. This question in NEET and JEE has been repeated so much, the graph. Suppose, let's say, this is potential on your y-axis, this is radius on your x-axis. Right, I have taken at the origin r equal to 0 means the center. R equal to 0 means the center. When I take a point r is equal to capital R, means the radius and this small r become equal. It means at the surface only. So this is the surface. This is the center. This is the surface. right? And then when I talk about the points between O and R, that is between O point and the radius, so anything that is inside, it means your small r, this is less than the radius. Small r must be here, radius is greater, it means the point is lying inside. And when I say R is equal to, R is greater than capital R, it means above surface we have taken, means any point that is situated outside. These are usually marked on the graph. Some are missing. Sometimes you have to tell it. So how will the graph be? How are we dependent upon small r? This is what we have to tell. So starting from inside this is independent. No value of small r is present. So nothing till here. Exactly, here at the surface also nothing, but here outside this is inversely proportional. So because this is inversely proportional to r, outside this is the graph that you get for all these spheres. This is important for you. Mark this as important. Questions, lots of questions you will find it from this. Note this down. Done?
Yes, ma'am.
See, after this, no, three things we have discussed: hollow conducting, non-conducting, solid conducting. One is left. This was hollow non-conducting, no, hollow conducting, hollow non-conducting, and solid conducting only. Solid non-conducting is left. Means when the sphere is solid also and the charges are accumulated inside. That also it can come. Just remember the formula, otherwise questions also we will see. So this is electric potential due to a solid. We are talking about non-conducting sphere. When I say non-conducting, it means charges are accumulated inside, and this is not hollow. It has mass also. That is what is meant by. Now coming to its formula, outside. This is K Q by small r, same. Coming to the surface is also same, KQ by capital R. Difference comes in potential due to inside. Remember, please mark this, especially if you want. This is not all this from here. This is not included in your syllabus. Means not even the formula for your CBSE syllabus you have to remember. So don't revise it during your board's exam. Clear, Shahid? This all these fair parts.
Yes, ma'am.
This is exclusively for your JEE, and all the things that we discuss here in this batch on Wednesday, this is for your JEE only. Things that we do not discuss in the class, but all the important things we try to cover. See, inside, this is a little different. Q by 8 pi epsilon. Or you can write it in terms of K also. 2 in the denominator also. Pi epsilon naught r 3 minus small r square divided by capital R square. This is the formula for inside. And one more case, special case is given, which is included only in potential due to solid non-conducting, means this part only. This potential at the center, nowhere you have to do, because that becomes zero. Electric field becomes zero. But at the center, the formula is 3q 8 pi epsilon naught r. So many a times which formula is used? That V center is 3 by 2 times V surface. More than any formula, this relationship is used. Graph also, just have a slight knowledge about the graph. Graph for this is not very important the way it was important for the above one. R. So again, all the same points. R is equal to R. R at origin. R is less than R. R is greater than R. All these points. So here it keeps on decreasing, and ultimately it becomes parallel to your x-axis. This is how the graph looks like. All right. Note it down. This is important for you. Especially this formula 3 by 2 V surface. Many questions, because otherwise what you will try to do, you will try to solve them and take their ratio, means this and surface one. But you know, you can look at the formula. This is very obvious from the formula that this is 3 by 2 the surface. But this you should try to remember it. Note it down from here.
Done, ma'am.
Just one question, Shahid. All right, then I'll leave. Just one question. See here, this question says that find electric work done in bringing charge Q from A point to B point in a sphere of charge plus Q distributed uniformly through volume. How will you start this question? Yes, Shahid. Work done, you have to find out. What would be the steps then?
To find the potential.
Work done would be
Q into V.
Q into V. All right. This is right. Work done from A, bringing it from A to B. This would be charge multiplied by potential. What would be the change in potential?
KQ by R.
KQ by R, it would be the change in potential. I'm asking whether it would be, it is from A to B. So VA minus VB or VB minus VA?
VB minus VA.
VB minus VA. So how can you write VB minus VA in one single line? These are two different cases. A point is at the center. First, tell me, Shahid. Read the question and tell me which case is this out of all the spheres you have written. Which case it would be? Which type of sphere it is?
Conducting sphere.
Which type of conducting? Solid, hollow?
Hollow.
Hollow. C. Firstly, it is said charge is distributed uniformly through sphere. So it should be conducting or non-conducting. Charge is present within the sphere uniformly through the volume.
Non-conducting.
Non-conducting. Remember here I have told you, when something is through the volume, the charges are through the volume, then we say it is non-conducting. Now, see, nothing is mentioned regarding hollow or solid, right? It is just given a sphere. So by default, when nothing is mentioned, you have to assume by yourself that this is a solid sphere if nothing is mentioned. For hollow, it would specifically mention you that this is a hollow sphere. Now, charge at B point. So B is at surface, inside or outside?
On the surface.
Surface. So what would be the formula? So this
KQ
KQ,
by R.
KQ by capital R, small r,
Capital R.
capital R. See this, at least this identify when nothing is mentioned, this is solid. And since it is given through volume, so this is solid, non-conducting, means the case which you have just written. This is that case. All right, minus. What would be VA? What should be VA?
Q by
2 by, you must have written it somewhere.
Q by 8 pi epsilon naught R.
2 by 8 pi epsilon naught r. Q by,
Yeah.
yes, Q by epsilon. Since we are writing it in terms of K, let's write it here in terms of K only. That would become K by 2R. K is 1 over 4 pi epsilon naught. 4 when goes in the denominator and gets multiplied by 2, that only becomes, no, 8.
Yes, ma'am.
You can write it as this. Otherwise, how will you solve? So yes, Q, C2 will multiply here. Now you have your answer, minus KQ by 2R. This is your work done. Right. What you can do, you can write it as minus KQ small q by 2R also. If depending upon which type of option you are getting. Sometimes options are in terms of epsilon naught only. So that time you have to mention minus KQ. This becomes 8 pi epsilon naught R. Clear?
Yes, ma'am.
Note this on question you have written already.
Yeah, ma'am. I wrote.
The question you have written already. Note down the solution quickly. Let me know. This was the last question for today. Now from this section, axes we have not done. See the questions, electric field on the axis of a circle, that we did for electric field. For potential, we do not have it in the CBSE syllabus. So that we'll be doing in your JEE, means the next class, that we have to do. And for long wire also we have not done. So long wire, partial differentiation we have done. Do you remember partial differentiation?
Yes, ma'am.
That can also come, partial differentiation. Okay, we'll discuss it once. Revise partial differentiation and come.